Okay, hello everyone. Welcome to another OpenShift Commons community call. And today we have a very, very special guest. It is Kevin Connor. If you remember Kevin, he was one of the OGs in Istio. Can I say that? But here he is. Well, you have
Nearly, no, not quite as early as some of them, but I was slightly late. I was like 6 months after everybody else, but close.
so close enough, close enough. But we're so happy to have you here and to learn about CEL Playground, which is the common expression language. And I've played with it. It's wonderful. And I'm excited to hear more about it and share it with the community. So Kevin, if you can introduce yourself and then I'll hand it over to you.
Yeah, that sounds great. Oops, sorry, too far. My name is Kevin Connor. I currently work for Getup as the Director of Engineering. Chief Engineer is another title they use, but my official one is Director of Engineering. I've been with them for a while. My background is very varied. I started off as a kernel programmer doing network and SCSI drivers. Went into Java, where I ended up doing lots of spec work for W3C, for those of you who remember SOAP and Oasis, transactional stuff like business activities and the like. Did JCP spec as well for batch. Then moved into Go because we started developing Istio, so I got in with that. Ran quite a few teams at Red Hat in and around those kind of technologies, cloud-based technologies running on Kubernetes. Then left to go for a startup, and now I'm at my next startup, which is Getup Cloud. I'll talk very quickly about Getup. So Getup are a company who have been involved in the Kubernetes space for quite a long time. There are two aspects to the company. There is the management side for Kubernetes installations. So they manage installations on behalf of their customer base, our customer base, should I say. We also do a security side to it as well. And we have a number of open source projects which are associated with that. CEL Playground is one, which we will talk about today, as well as other things. Marvin is another open source project which allows you to run checks using CEL within your Kubernetes environment. So you can run checks within that environment. And Zora is an orchestration tool which manages Trivy, it manages Popeye, it manages Marvin. So it schedules scans for those and then reports them back to a SaaS application. So that's a bit about Getup. This picture was my first trip to Brazil, which was February of this year in Sao Paulo. So there's a few of the people who I work with on a daily basis. So what are we going to cover today? First, we'll cover a bit about CEL Playground so that you can get an understanding of where the background is, why it was started. We'll then do a quick tour of the common expression language for those of you who haven't seen it before. I'm really going to try and move fast through that because the interesting part is at the end where we talk about the Kubernetes use cases. And there we have a new version of CEL Playground, which is in the works. So this one I will be running locally, but it will allow us to do things with webhooks and validating emission policy at the moment. And then we will get the others implemented as quickly as possible. And then we'll hopefully have time for questions at the end. So that's what we're doing. So let's move on to CEL Playground. So what is CEL Playground? CEL Playground is a WebAssembly environment. It is running within your browser. So everything that you do is completely hosted locally. Completely executing locally. There's nothing going to backend servers other than the initial download of everything. You can use it to develop CEL, you can test CEL, you can share various things. I'll show you that later on. And hopefully you can use that to avoid mistakes getting into production because you can test it out within that environment before you actually put it into Kubernetes and make it go live. So the original idea came through really Matthias, who I believe is on this call. He had been working with a number of the customers within Getup, so this was prior to my joining. And they were using CEL, but they were struggling with CEL. They were wanting a place to try it out, to learn it, to just play about in a safe manner. So Matthias started asking about it, talked to Joe about it, and decided, you know what, this doesn't exist, so I'm going to write it. So he wrote the very first version of CEL Playground, and that's what is running live today on the website. But it really came out of a need that he had for our customer base to learn CEL, to play around with CEL, to get them confident in CEL. And we're hoping that this is something that you're going to find of use as well. CEL Playground is now being used in quite a lot of countries worldwide. The graph at the bottom right is slightly concerning because it takes a dip towards the end. I'm hoping that's an error in the rendering of the graph and not an indication of where we're going with CEL Playground, but it has taken quite an upward trend since July of last year. So hopefully that's going to continue. So first I'll show you a quick demo CEL. If you want to follow along, that's the URI where you can access it. I'm just going to show you a little bit about the actual environment first. So this is what CEL Playground looks like. If you go to the website now, this is what you'll see. There are example boxes there, so you can see an example. This is the expression part which you're going to evaluate. The part here on the top right is the input data that can be accessed within the expression, and then the bottom right is the output along with the cost of the expression. So we can execute that, and in this case we just get a response of true. It's looking to see if the account balance is less than the withdrawal, or there's an overdraft protection limit. So in this case, we have a balance of 500, a withdrawal of 700, but there's an overdraft protection limit there. So it allows us to execute it. So that's really what the current version does. There's no structure to it that we would recognize from Kubernetes, from resources within Kubernetes. It's raw data on one side, raw expressions on the other side. So this is part of what we're going to change. So yeah, that's CEL. You can just give you another example. You can just type simple expressions like 1 + 2, and then you get the output on the bottom. So it's not just true or false. It's not just predicate expressions. Can everybody see this screen okay, by the way?
Yes, I can.
Is it legible?
Can you make it a little bit bigger?
Sure. How's that?
Perfect. Yes, thank you.
Okay, and I'll try and remember to do that on the other screens as well when I get to those. If not, please remind me. Okay, right. Oh, sorry. Right, so let's get back. So we're going to do a quick tour of CEL. This is really just talking about what CEL is, what it allows you to do, what the expression language is, the different functions that you can use, etc. Then we'll talk a bit about the extensions that Kubernetes adds into the mix. And that's really to satisfy the Kubernetes use cases. And then later on, we'll do some work on the Kubernetes use cases and show you some of that being evaluated. So let's start with Common Expression Language. So this was developed by Google. It's a small, fast executing expression language. It's embeddable, so we can integrate it. The CEL Playground is written in Wasm, Golang. It has, all it's really doing is incorporating the CEL library within an application, and then we're converting that to WebAssembly. We're compiling it into WebAssembly so that people can download it, and anybody can do that with CEL. It's very, very quick. It's very extensible, so you can add your own extensions as Kubernetes has. It also comes with some benefits as well. So one of the benefits they use is, if we go back, if we take a look at the cost expression that we were showing in CEL Playground, you can actually set limits on that as well. So you can constrain the expression when it's executing in your environment so it doesn't consume too many resources. And Kubernetes makes use of that aspect as well. You can have logical expressions with it, relationships, arithmetical expressions. There are conditional expressions, and it looks like I have a trailing optional one there, which I thought I'd move to another page, so I obviously have a mistake in my slides. But yeah, so you have all the normal operations that you would expect there. Types, again, they're pretty standard types. You have unsigned and signed 64-bit integers, doubles, booleans, strings, bytes, lists, maps, durations, timestamps, and obviously the null as well. So those, again, are pretty standard. If you've been using C, Golang, those kind of languages, you'll be used to using those types. It also has conversions. So by default, CEL will not do conversions from one type to another. But the way you do it is just like, for example, bytes. You can do bytes, open a parentheses, put the string in there, and it will convert string to bytes. So you can get bytes. Again, same with integers. If you had an unsigned int, you can do the same thing. There are conversions for most things. There is actually a better way of doing it, which Kubernetes introduces, so we'll talk about that later. There are macros as well that are part of the language that allows you to examine the data that you have. Has just tells you whether something exists. All is it evaluates a predicate and makes sure that it's true for all entries in a list or a map. Exists is similar, but it just has to evaluate to true once. It's not that every element within the list or every element within every key within the map has to exist. It's just the one has to exist. You can also transform maps. So there's a map command which allows you to transform the data. So in this case, we're just doing a map from X coming in to X plus 10. So we're just adding 10 onto every element of the list. There's also a variant of that allows you to filter using a predicate. And there's also a filter which allows you to choose elements within a list. So these are quite useful macros to have. And actually within Kubernetes for quite a long time, we made use of those, especially before optional was there. Functions as well. You can do string contains, you can do string ends with, string starts with, you can do the sizes for various structures. You could also do regular expression matching. And there are a number of timestamp and duration functions as well that you can use, which I'm not going to go into here. I don't tend to use those, but I do know other people who have used those. So going on to Kubernetes expressions. So the optional expression, which was the one I mentioned earlier that I thought I'd moved and obviously left a dangling reference to it. That is very useful because it introduces the concept of an optional value. So if what you would previously have to do was say if has an entry within the data, then you go on and do it. So it was has was acting as a guard around accessing the data. So you always knew that the data was there. Optional expressions gives you a short circuit. So if the data is not there, it gives you an optional value, which is null. And that continues for the rest of the expression. So you only have to use it at the beginning of the expression, and then it continues for the end. But it allows you to be more succinct in your expressions. It allows you to reduce a lot of the complexity. We have an example that I'll show you within the CEL Playground later on. Cross-type numeric comparisons. So we can now actually do comparisons with floats against ints, against unsigned ints, which we wouldn't have been able to do with CEL. We would have to convert it to the type and do an explicit check with that. String library extensions as well. So we have things like the characterat and index. We have the searching the strings to see where the last index of a particular string was, the first index of a string was. Converting to lowercase. We can replace strings within it. So replace AB with YZ, do it for a count of 2. So replace the first two instances of AB with YZ. We can split strings, creating a list. So that would give you a split that would create a list which would have ABC as the first element, then DEF, then GHI. And we can also do substrings, the from and to index of the string. Trimming, again, removing the white space either side of the string. We can format it, and we can also join arrays into a string as well. So we can have 1, 2, 3 as a list. Then that can join, and we end up with a string with them separated by commas. The next extension that they added in Kubernetes was URL handling. So you can check to see whether the URL, the string is a URL, is a valid URL. You can get various aspects of it, like the scheme, the host, the port. You can get an escape path, and you can get the query parts of a URL. So those are useful in some instances. Quantities was also added, so we had the ability to reason about quantities within the Kubernetes use cases. Is it a quantity? Is it greater than something, less than something? So you have comparative operators there. You can convert to a float or an integer. You can actually test to see whether it is an integer, or whether it's something like a float that maybe has milli parts to it or not. We can add and subtract as well. So again, there are examples of that in the CEL Playground, which we'll comment to in a bit. The next part that we're going on to is regex expressions. So we can find based on regex. We can find all instances based on regex, not just the first one. We can also do list manipulation, so searching a list for the first or the last index of a particular entry, comparing. For lists of comparable types, we can find out whether the list is sorted. We can find out the maximum value, the minimum value. And if there are summable types, so numeric values, then we can also sum the entries and get a total sum from those. Now, authorizer is the final extension I'll talk about, and this is quite an interesting one because this allows us to contact an authorization service. So this is the only extension, the only feature within the Kubernetes CEL environment that actually allows us to contact an external service. So it can take quite a bit of time for that. We can do resource checks against a particular group and a resource. So in the first instance, we are looking for pods. We can look at sub-resources as well, so the status of the pod. We can check resources which are in a particular namespace with a particular name, and you can use those in any combination to get to the final resource check. Once you have your final resource check, you can then execute the check command with the particular verb that you want to test. So in this instance, it's the watch verb, and that will come back with a decision, and you can check whether the decision is to allow it or whether there was an error as well. So those are the authorizer extensions. That was for resource-based authorization. Non-resource-based authorization is basically path. So requests that are coming in, you can get an authorizer for a particular path. So in this instance, we have /health. You can check for an HTTP verb. In this case, we're doing a get check. And again, that returns a decision where you can check to see whether it's allowed or whether it's errored. There is also a third use of the authorizer, which is to actually test whether a particular service account has access rights to something. So you can get an authorizer for a particular service account by calling service account, given the details of it, the namespace, the name of the account, and then you can just run any of the previous checks. So checking for a particular resource to see whether the service account has that access to the resource. So that's the last part of the extensions that Kubernetes allow. So now we'll go back to we'll go back to PlayCell, the current version of it, and we'll take a look at some of those just so that we can show you what it was like. So there we go. So here is an example showing URLs. So the first one is URL is obviously a guard to make sure that the reference that we're looking at, which is on the right-hand side, is a valid URL. If it is, it then tests to see if the scheme is HTTPS, tests to see if the host is example.com with a port of 80, host name example.com, port 80. The escape path is /path, and it does a query and checks the size of that to see whether it's 1. So we have 1 entry here. So if we run that, that should be true. Okay, so that shows URL manipulation here and some of the queries that we can do with that. If we do duration and timestamp, this is a simple example here. Again, there's a guard on this one, has object expired. So if we have an object.expired on the right-hand side here, it then checks the timestamp to see whether the created plus the time to live is less than the expired time. Okay, so we can, run that, and again, that comes back with true. So if we decide to, if it came back with true to say that it expired because it was greater than the time to live. If we change the time to live to 10 minutes, then it comes back with false to show that it hasn't expired. The next one that I'll show you is, where is it gone? Where's the optional? Optional, there we go. So this is the optional one that I was talking about before. So object exists, then we have the optional value here. So it looks to see if foo exists. If it doesn't exist, it comes back with an optional which says there's nothing there. We can have an alternate value which says or fallback, or value, which is if it doesn't exist, then we give this as the response. So in this case, because foo doesn't exist, we expect to see fallback come back. So we have fallback there. If we add in foo and then run again, then we get the value of foo back. So that allows us to simplify a lot of the expressions where we used to have guards in. We used to use has as a guard to make sure that it existed before we accessed it. And this could go to do foo bar. And now we go back to fallback because bar doesn't exist. Okay, so again, this is what I was talking about before when I said that you only need to use the optional operator once, and then everything to the right of that becomes optional automatically. So any point in that doesn't exist, you end up with the optional value, and you can then use that to trigger the OR value at the end of the expression. Okay, so those that's a kind of brief introduction to CEL Playground, to CEL. We've done that. The next thing I would like to talk about is the specific Kubernetes use cases. So obviously, the Kubernetes extensions, they're there because of use cases that the community has had. The first one we're going to talk about is webhooks. Now, for those of you who have used webhooks, you know that those are remote services. They intercept various parts of a request coming into the API server. There's a mutating webhook which gets to run first. So they will keep running until the mutations are finished. And then once the mutations have happened, so a webhook that would be changing the resource has finished changing the resource, it then goes to the validation webhooks to make sure that the resource that you're now looking at remains valid. If that passes that check, the validation check, it then goes to the API server to execute. Now, there are quite a lot of downsides to this. The first is that the API server has to invoke a remote service. Okay, so that can be time consuming. It could potentially fail. Your service may go down. It currently has very coarse-grained access rules. So you can look at things like, in this example here, we're creating pods. Its scope is namespace. So basically, we're looking for all pods that have been created with this rule. We can filter using labels. So we can add namespace selectors and object selectors, which will constrain it further, but it's still quite fine-grained. And of course, all this is happening. All the webhook execution, whether it's mutating or validating webhook, is happening in a remote service. So once it decides to call the webhook, you have to wait for the webhook to finish. The webhook integration for CEL improves this because it adds something called match conditions into webhooks. This allows the API server to run these expressions within the API server itself. So we can have much finer grained control over which requests will go to the webhook and which requests can bypass it. So in this example here, we're showing that if there is a request that comes in and it's for a lease resource, then we're going to bypass the webhook. That will return false in the first expression, which will say that it's the webhook should not be called. The second one does something similar. It's excluding kubelet requests. So anything which has system::nodes in the user info groups, that will also be bypassed. So that will have a bypass of the webhook. Any other request which doesn't satisfy those will be sent to the webhook, so the webhook can then determine what to do with it. That cuts down the amount of traffic that goes to webhooks. You can really constrain the conditions upon which the webhook will be invoked, which adds to performance improvements, obviously, when you're calling the API server. So when you're running match conditions, you have access to various pieces of data. The first two are pretty standard. Oh, this is misaligned. Something's happened to the alignment here. So object is the object from the incoming request. So if that's an update or that's a create, then it will have a value there. If it's a delete, then it will be empty. There'll be nothing there because you're removing the resource. Old object is the previous version, or should I say the current version, which is stored within etcd of the object of the resource. So if this is a create, that will obviously be empty, but if it's an update or a delete, then it will have the current contents there. So you can use that to check various things within that resource. You have a request object, which gives you the request portion of an admission review. So it doesn't include object knowledge object because we have those separately, but it will give you everything else for request, and we'll show a bit about that in a second. And then you have the authorizer to allow you to check authorization, to run authorization checks against the incoming request or the user who's executing the request. There is a short circuit at the bottom as well for request resource. That is a particular resource check on the current resource. So you don't need to go through the authorizer to find it. It's provided for you. So you just call authorizer.request resource, and then you can do the check on that. So let's do a demo. So this says placeL.undistro.io, which is the version that we have up running. That's the current version that's live. But I'm going to be running this locally because this is work that we have we're developing now. It's in progress. So if I go to the webhook one, so I have a number of examples here I can show you. So let me zoom in again. I think, is that okay for everybody?
Thank you.
Yeah.
Perfect.
So on the left-hand side, we have a proper Kubernetes validating webhook configuration. This is what we deploy. This is what we expect to see. It's no longer just a CEL expression. All right, we're now talking in a language that we're familiar with from Kubernetes. We don't need to do any translation between it. So in this case, we have a validating webhook configuration. It has the two match conditions that we showed earlier on. I dropped a third one because that's not relevant for the expression. So we're going to play around with those for a bit. On the top right-hand side, we have the data that's going to be part of the request. This is a create, so the original content, the old object is empty. The updated content, so this is object within the expression. So this shows that we're dealing with a Kubernetes deployment with the data there. We have the request data. So it came in as an apps v1 deployment. We have a create operation, the namespace default. We have a username of admin with the groups associated with the user. So this is really just mapping a request, the request information. It is currently free form within this UI. It will be a structured editor at some point. It's something that we're working on. We have a couple of people who are going to be working on that in the near term. Authorizer is empty here because we're not using any authorization requests, but I'll talk about authorizer in one of the later examples. Okay, so let's give this a go first. So we have two match conditions. We know it doesn't include leases. We know it doesn't include kubelet requests. We also know that our content doesn't satisfy either of those, so we expect this to run to the webhook. So if we execute it, this is the response we get from our integration. So we see exclude leases. That was true, so that's passed. That means that's not. So it currently matches that one. The second one, exclude kubelet request, that returned true as well. So since both of those checks return true, the webhook will be executed. So that request will now go to the webhook. In this case, it's a validating webhook. It will then validate to see that it matches the conditions. Right. If we were to choose a second version of this, so this is the we're going to test the exclude leases part of it now. So this one actually is a lease. So we don't expect this to go to the webhook, right? So that should return false for excluded leases, and it actually does. So we get a response back of false excluded leases because it matched the coordination.kubernetes.io group and it matched the leases resource. Okay, so if we go to the request, we can see the information there from the request. Okay. The next one I'll show you again. This is the kubelet showing this this one locking the webhook. So this one works because there's a group system nodes. If that is part of the user info within the request, so it's actually come from a node, a Kubernetes node. Oops, sorry. Then it will bypass the webhook and go direct to the API server. So if we run that one, we then see that the exclude kubelet request is now returning false. That is because when we look at the groups within the request, we see that it does have the system nodes there. Okay, so those are the dealing with requests. Dealing with authorizer. So this again, this is mocked up. So this is just the default. We can specify paths, groups, and service accounts. There's nothing there. So that defaults to unauthorized for the request. So the match condition that we're looking at this time says if the person calling has on the group admission registration for validating web configurations with the name rawback.myexample.com, and they also have a break glass, they're allowed to break glass, then they will bypass the webhook. Okay, so anything which has a group for that, for the authorizer, will break it. So we don't have anything here, so this is something we don't expect to bypass, so it should go to the webhook. So if we run that, we end up with the break glass check coming back with a result of true, which means this request will go to the webhook. If we go to this one, so we can now see what the data that we're mocking with an authorizer looks like. So this shows that we have a group, which is admission registration.kubernetes.io. Within that, you can specify resources. We have one for validating webhook configurations, and we have it because it has an empty string there because it's not a namespaced resource. The name of the webhook configuration is rawback.example.com. And the check is break glass, and the decision is allow. So when we do the check here, it will come down, get to this decision part, and that will actually allow us to bypass the webhook. So we expect to see a result of false when we execute this. And indeed we do. So we come back with a result of false, and that shows the way the authorizer works. It shows the way that request works. Again, these are unstructured editors at the moment. Primarily because I'm not very good at front-end UI, I rely on other people with those skills to do that. But the intention is that these should be proper contextual-based editors for request and authorizer, structured editors for those once we get to the point where we can support this live. So that is webhooks, right? I'm going to go back to now talking about a more interesting case, which is validating admission policy. So validating admission policy is an alternative to the validating webhooks that we have been looking at. It covers a large number of cases, but not all, you still have your kind of get out of jail free card to use the actual webhook itself rather than the policy for those instances where the policy doesn't quite cover it. But there's a lot of flexibility within here. Most of your use cases will very likely fall under validating admission policies now. This runs again within the Kubernetes API server. So it's not executing a remote service. It's doing the validation within the server itself. It consists of 3 different resources. The one which we will talk most about today is the policy itself. So that allows you to define a policy and what the validations will be. And then there is a binding object which says, that allows you to specify which resources it will actually apply to. And then you can have parameter resources as well. So you can actually parameterize your policy based on how you bind your policy into, based on the parameters that you bind into the policy. The result of this can actually be a deny, and in other words, the request doesn't go through, which will also audit the request. Or you can do a warn, in which case there will be a warning about the request. And for warn and audit, you can use together. So this is actually a list. You can do a warn and an audit, or you can just do a warn, or you can just do an audit, or you can do a deny, which will deny the request and audit it. So audit just audits the request. It doesn't issue a warning of it. We have a number of areas where we can use CEL expressions. The first is that it allows us to define variables, which we'll go into in a bit. There are match conditions, which are very similar to the match conditions that we saw with the webhook. We then have the validations themselves, which say whether the request is actually a valid request. And then we have the ability to actually include annotations within the events if the request goes through. So we can add some audit trails into the changes and why the changes were made, which parts of the policy were successful. So looking at the objects that the expressions have access to, in all the cases that I mentioned before, apart from the audit one, they have access to the authorizer and the authorizer request resource. The audit one doesn't. But we have the object and old object that we talked about before. Same conditions apply with regards to create and delete. It's exactly the same meaning. Request is the same as we had before with the webhook, same meaning. Parameters, these are the optional parameters that are bound through the binding. We're not going to talk about that yet because that's not something that I've implemented within our support for validating admission policy. I still have to work out the best way to do that because the parameters within the Kubernetes implementation, those are CRDs in their own right. So we define the CRDs, we then bind them into the policy. So you have to actually specify what the kind is within the binding. And I don't know whether I need to support that or whether we can do a short circuit and just support parameters. So that's a TBD for now. The namespace object, which is a new one, that actually just gives you the namespace where the resource exists. So you can do things like checking the namespace for particular labels, which is one of the examples I'll show you. We have the variables. So those are the variables that we will define within the policy. You can then access them. Those are actually executed on demand, which is something, again, I'll show when we come to looking at it running within CEL Playground. And you have the same authorizer capabilities that we talked about with the webhooks. So again, you can check to see whether a particular person or a service account has access to resources or paths within the authorizer. Okay, so variables. What are variables? Variables are expressions that you define, and they can be used within either other variables if they come before the use, or they can be used in validations, or they can be used within audit annotations as well. So this shows we have four variables that are defined. We'll actually come across these later when we look at CEL Playground. One is for an environment, and check to see what environment exists on the namespace, if there is one, defaulting to prod. The second one is whether something is exempt from the validation rules. So that just looks for the object that's coming in to see whether it has a label of exempt set to true. Containers, all that does is retrieve all the containers within the template. So this is a deployment that we're going to be looking at. And the containers to check uses a filter to just look at images that contain example.com within their name. So those are examples of variables that we can use within a policy. Sorry, I meant to, oh, actually, no, I mentioned the on-demand earlier on. So, match conditions. So these are the same as webhooks. It provides a fine-grained request filtering for the validation policy. Again, it runs within the Kubernetes API server, and for validations to run, all of these have to be true. So if they're not true, then you won't get any validations running. And again, we'll show that later on. So these are the same ones that we showed earlier on, so I don't need to go over those again, but it's the leases and the system nodes bypass that we used within webhooks, but now applying to validating admission policies. Validations, these are the expressions which determine whether the request will be accepted or not. So these must all be true. If they error, then you can specify whether that will fail. There is a way that you can specify whether that will fail the validation or whether it will just ignore it and carry on without the error. But otherwise, all the expressions have to be true in order for the operation to continue. So this has an expression here which says either the request is exempt from this policy, or all the containers that we are to check must start with the name of the environment plus the dots. So in this case, prod dot something would be the image name. And again, we will come across that in the examples that we show in a bit. Audit annotations. This is the final bit that I was talking about with where we can use CEL expressions within validating admission policies. This allows us to add in additional information to the events that get created when the operation goes ahead. So in this case, if the request is valid, so it has a replica count of greater than 50, then we will have an extra annotation on the event which says deployment spec.replicas was set to whatever the value happens to be. If the validation fails, then it will execute the message expression instead, and it will return that to the caller. So the caller will get deployment spec replicas set to blah as the reason for the validation failure. Okay. And again, we'll come across those within the demo. So now let's take a look at that. Again, this is something that I'm running locally because it's a work in progress. But we will get it up on the CEL Playground as quickly as possible. So this is validating admission policy. It has the same structure as the webhook one. You have the additional namespace entry in there, but otherwise content, updated content, request, authorizer are there. We don't have parameters in yet. That's the one thing that's missing. Let's take a look. This is a simple validation. Hopefully that's legible. I don't know whether I've gone in too far or not. There, try that one. Okay, so this is a simple validation. We'll take a look at the deployment that we're looking at here. So the expression is object.spec.replicas has to be greater than or equal to 3 for the request to be accepted. Now in this case, we have replicas equal to 3, so this should return true, and we should be able to proceed with the request. So we run it, and that's indeed what we get. We get a result back of true. If we were to change this to 2 instead, so now we know it's going to be invalid, it should be rejected. we get a result of false, and we also get the message back saying all production deployment should be HA with at least 3 replicas. So that is what the person invoking the request will see. So whether that's kubectl or something else, they will get that back as the response. Okay, so that's a simple validation there. Let's look at variables. Okay, so this is the one that we talked about earlier on, where we have environment, we have exempt, we have all the containers within the request, and we have the containers that need to be checked within the request. Okay, and then the validation at the bottom. So if we run that, we see that we get the details for the variables back. Right, in this case, we have the list of containers. So this is all the containers within the spec. I can do a quick change to show that. So let's copy that, put in an extra image, but instead of example.com, we'll put test.com, so it will not match the filter. If we run that again, let's move, where are we? So now we see that we have containers there as the first image, which is the example.com one, then has the second image, which has test.com. We also have containers to check. So this only has the example.com one because that's what matched the filter. If we go back up to the top, we have the environment, which was the first expression. That has been evaluated to prod. And then we have exempt, which is evaluated to false. So if we look at, so the environment is looking at the namespace object. So let's take a look at the namespace object. So we have a label in there which says environment prod. So that is what we're expecting to be on the namespace. So when it has prod there, everything works fine. The image within the content, if we find the image, is prod.policy.example.com. Okay, so it begins with the environment name and a dot. So if we were to go to the namespace and say change that label to demo instead and run it, okay, we see that the variable has changed to demo. And if we go down to the bottom, we see that now the validation is returning false, and it says only demo images are allowed in namespace false. So that actually comes from this expression here, where it has taken the value of the variable from the environment variable that we calculated before and returned that to the caller. Okay, so that's that part. Let's now take a look at, so we've done the environment, let's take a look at exempt. Now, this is saying that because this is a demo image, we shouldn't really be deploying this into default. But for this instance, we want to do that. So we have a get out of jail free card, which is we can use an exempt label on our deployment. So let's change this to true to say that now we're exempt, you should go ahead and deploy it. If we execute it, we'll notice that now the validation result has come true, but we'll also notice that as far as validating the variables is concerned, it is only validated, it's only executed the first one, which is exempt. Now that is because it was the first part of the expression which was being evaluated. And when that is first referenced, that's when the variable part will then go and be evaluated. Because this is an OR, we know that the next part of that will never be executed because exempt return true. So because exempt return true, none of the other variables, containers to check, won't get executed. Sorry, I keep doing that. Because containers to check doesn't get executed, then containers doesn't get executed. So those ones won't get executed. Okay, and we won't see environment either. So that is kind of variables and validation. Match conditions, it's very similar to what we had before with webhooks. There is one difference though, which is all the match conditions, if they don't evaluate to true, then you will not get validations run. So in this instance, the exclude lease, the exclude kubelet request, both evaluate to true. So we get to run the validations. So we know that this is the validation. So either it shouldn't contain demo or the namespace must be a demo namespace. Okay, and we have a we have here in the object a namespace of default, and we have a name of Kubernetes Bootcamp. But if we put in demo there. Then now it's the validation is returning false because we're claiming that it's a demo deployment that is running within the default namespace. Okay, so we'll put that back to there. So if we now look at the match conditions, so what I'm going to do is I'm going to modify the request so that we have a system nodes group. So we go to the request. At the moment, this is an authenticated user, and it's got a myadmin group in there, but we're going to change that to nodes. So that should return false for the exclude kubelet request, which means it won't evaluate the policy. So there's no need to evaluate the validations. If we run that now, we can see that only the match conditions come back because one of them was false. So it doesn't go into the validations. It doesn't run that because we know that this is being bypassed. The validation admission policy doesn't apply to this particular request. So that's match conditions. Audit annotations, we talked about those earlier on. So this one is if we have replicas greater than 50, then it's a valid request and we will audit it. We will put the data, we'll put the audit message back within the event. If it is less than or equal to 50, then we return a message expression to the caller with the details of that. So let's take a look at the request that we have at the moment. So we're looking for replicas, and that is currently 3. So we expect replicas to fail. If we run it, that's indeed what we see. And we see result of false, and we see the generated message deployment spec replicas set to 3, which is the value that was passed in. If we change this to, say, 53, which we now know should be valid, and run it, we get the result of true, but we also get the audit annotation coming back as well, saying that this would result in an audit annotation being applied to the event. And the annotation would have a name of higher replica count, and it would have a value of deployment spec replicas set to 53. So when you see the event within your stream, you can see that message being associated with it, so you know what the context was. Okay, so that's audit annotations, and that is the end of the validating admission policy part. So let's go back. So now we'll get on to the parts which I haven't yet implemented. Part of this is, oh, sorry, go ahead.
Just a really quick time check that you have
Sure.
5 minutes. I am loving this. So I hated to interrupt you, and I just wanted to let you know.
That sounds good. I'll go through these quickly. Okay. All right, so claim mapping is, it runs on the API server itself. So you actually specify the command line option on the API server. It's a set of rules which allows you to actually map parts of a response from a OIDC invocation, an authentication invocation. So you can map the username that comes back within the JWT token to something else. You can manipulate the groups, you can manipulate the user ID, you can add extra data into that as well. Okay, and then there are validation rules as well that you can add to that to make sure that the user coming back is valid. Okay, one of the examples being here is that shouldn't start with system : because that's obviously essentially root access within Kubernetes. Okay, so that's that. Authorization configuration, this is another command line option to the API server. So again, it's running on the back end. It's not something that we would tend to come into contact with from a user perspective for Kubernetes. So what this allows us to do is actually send have a chain of authorization requests, authorization checks that need to be invoked. Before this, you could have, as part of your checks, you could have a single webhook. Now this allows you to add in multiple webhooks, reference multiple webhooks in this. So we can see from the example here, I don't know if this is too small for people to read, but we have a webhook that's being invoked, and then there's the node check, then the RBAC check, then there's an OPA webhook being invoked there. So these are all going through authorization requests to see whether it will allow the request to go ahead. You can access the subject access review there. with the, sorry, this was in the match conditions, should I say. So you have the resource attributes, non-resource attributes, the user information, the group information, the UID, and the extra information that came from the authentication part that we saw before. Custom resource validation. If you've been using Kubernetes for any amount of time, you've probably created custom resources, you probably added schemas to them. Part of the validation is, part of the schema is that you can extend it with validations, ex-Kubernetes validations. You have rules there. For example, this one says self.min replicas has to be less than self.replicas, less than or equal to self.replicas. And self.replicas has to be less than or equal to self.max replicas. Okay, so just making sure that the replicas count is within the bounds that you've set. You have access to the old object, you have access to the current object. Again, that's the same as we had before with the validation admission policy and the webhooks. You can bind these validation requests, validation expressions to many parts. They have different ways of accessing depending on whether it's the root object, you have extra data there. If it's an embedded object, then it's like a normal object field reference. It can be a map as well if it's additional properties or an array, so you can use an index for that. Or it could be a scalar value as well, in which case it takes on the value of the scalar. So that's it. Questions? Before we get onto that, I'll just do a quick roadmap here. So obviously we're filling out these. Most of these are on the way. Validating admission policy is mostly done on the back end. The webhook is mostly done on the back end. CRD validation still has to do. Authorization, those are the two server-side ones that we talked about, authentication and authorization. So those have to be done, but those are match conditions, so they're pretty simple compared with the ones that we've already implemented. And one of the interesting ones, sorry, yeek. Didn't mean to do that, sorry. There we go. One of the interesting cases is testing on live clusters. That's something that we want to add. So instead of actually mocking a lot of this information, we should be able to pull it from the cluster. That's one of the aims that we have, one of the eventual aims that we have. So please give us feedback. We've already had feedback from the likes of Jordan, Liggett, and CC. We have presented at a number of the Kubernetes SIGs. So the SIG API machinery one, we presented there to the CEL group as well. We did another SIG, which is escaping me at the moment. But please, if you see any issues, let us know. If you see any, if you have any requests for functionality, please add an issue. Please create an issue, and we'll get onto that as quickly as we can. And if you're using CEL already, we do have an adopters file now. So please just add yourself in there. Just add your name, a little description of how you're using that, how you're using CEL within your day-to-day work. And again, if you want to contribute, it's open source. We are more than happy to get contributions. You can either talk with Matthias, talk with myself, just create an issue, get working on it. If you have something that you want to implement, just please go ahead and do it, and we will obviously help as much as we can. There's a link there to the slides from today if you want to download them. It's just on the CEL part of the CEL Playground GitHub. So you can find it through that as well. Just go onto the presentations directory. So that was uploaded this morning. It should already be there for you to download. And that's it. So I think we've just hit time.
No, there's no time for questions, but we'll make sure that if anybody has questions, that how they can reach you. And there is the common Slack, so you're welcome to join us there as well. And I will ping you with other questions offline because, you know, we do have the next KubeCon to think about. And I was looking at your sandbox application, so.
Yes, I forgot to mention that. Yes, we have just recently, Diane's going to kill me. So we have applied to be part of the sandbox for CNCF. So if you want to add support for that, please do. We want this to be a community project, community-driven project, both from the Kubernetes side as well as from the CEL side. This is us just kind of giving something back to the community, and it's open for everybody to help out with.
And as somebody said in chat, it is a masterclass on CEL. Absolutely, thank you. Like, I mean, you know, my other CEL person is David Eads. So between the two of you, you know, maybe we can make something happen in Salt Lake City.
That sounds good. Yeah, I know David.
Okay, well, thank you again for joining us, and till next time, everyone.
Thank you, Karina. It's been a blast. Thanks.
Thank you.